In this video, we'll learn about how to use piecewise-defined functions. A typical example of a piecewise-defined function might look something like this. Instead of one formula for our function f, we have multiple formulas, and we're given instructions as to for which values of x we want to use those formulas. So in this example, we're asked to compute f of -3. And so the question we have to ask ourselves is, which of these cases, which of these three possibilities, matches up with the input x equals -3? And it shouldn't take us too long to realize that when x equals -3, that x value is less than 2. So that means that f of -3 uses the formula corresponding to that inequality, in other words, x squared. So f of -3 is -3 squared, which is 9. But if instead we want f of 4, then that input x equals 4 corresponds to the inequality x greater than 2. So for this input, we're going to use the formula -2x plus 10. So f of 4 is -2 times 4 plus 10, and that equals 2. Finally, if we want to know what f of 2 itself is, we're not going to use this middle formula very often. We're only going to use it when the input is exactly equal to 2, but in this case it does equal 2, and so in this case the input is f of 2, and so the output is 5. So that's it for piecewise functions. If we want to know what we get when we plug in a certain value, we just check the inequalities, and whichever inequality fits with the value that we plugged in, that's the formula that we use. Now, graphing a piecewise function can be tricky, but the basic idea is that we want to graph each of the pieces individually, and then we're going to cobble together one single graph out of the graphs of the pieces. So first we want to graph y equals x squared. And the good news there is that that's not a hard thing to graph. We know that y equals x squared is in our library of functions, and it looks like a basic parabola just like that. But since we only want to use y equals x squared when x is less than 2, really what we want is just the portion of the y equals x squared graph that goes up to the point where x equals 2, which is the point 2, 4. And in fact, we don't actually want to include that point 2, 4, because that would be the point where x equals 2, and we only want this for points where x is less than 2. So what I've drawn in blue here is the only part of the x squared graph that we actually want to use. The other function that we have to think of the graph of is y equals -2x plus 10. But that's a line, so it's not going to be too hard to graph that. We know that this line has slope -2 and y-intercept at 10. So here's the point 0, 10, and our line has slope -2, so it looks something like that. But we only want this graph, this line, when x is greater than 2. So that means we want to start at the point where x equals 2, which is going to be right around here. We don't actually want to include that point where x equals 2, but we want to go up from that point and graph everything beyond it. So 2 comma what? Well, the formula is -2x plus 10, and when I plug 2 into that formula, -2 times 2 is 4, so -4 plus 10 is 6. So when we piece these pieces together, the combined graph of our piecewise function, so this is going to be y equals f of x, is going to be built out of those two blue graphs that I've drawn to the left. So when x is less than 2, I'm going to draw the parabola y equals x squared, up until I get to the point 2, 4, and I'm not actually going to include that point 2, 4, so I indicate that I'm not including it by drawing an open circle. And then I'm going to draw another open circle at 2, 6. I'm starting to draw the linear function now, and I go from there. So I've graphed this part of the piecewise function, the x squared part. I've graphed this part of the piecewise function, the -2x plus 10 part. The only part I haven't drawn is the part here in the middle, where when x equals 2, y equals 5. And so I'm going to draw a filled-in dot there, because I really do want the point 2, 5. And so there's the graph of our piecewise function. It looks a little strange. It's in these disconnected pieces. Sometimes the pieces will be disconnected, sometimes they'll actually be connected to each other. But that's how you graph a piecewise function.